scenario. So today we will talk about modeling using linear equations, and believe me, these equations, though they are very familiar to us, we are solving these equations with matrix method from I don't know how long we are doing these things, but these could be really powerful in modeling mostly social science related problems, economics related problems, policy making, decision making, collective decisions. These are the key to understand. Non-linearity is not really essential to understand these things sometimes. So we will take a toy model, and from there we will move on to understand what kind of systems I can have and how versatile it could be only using linear equations and only in two variables. Then we will take some baby steps towards three variable problems, and I will keep that part open, an open question for you guys to explore. Okay, so we stopped at this point where the classification of linear systems were already done, and we understood that in the trace versus determinant plane of that A matrix that we had, in the trace versus determinant plane, depending on the positive or negative signs of the trace and the determinant, and also the zero values of the trace and the determinant, you can have different kind of beautiful dynamics, right? Where the eigen directions were very much dominating. We also came across some interesting lines in the phase plane, like manifolds, stable manifold, unstable manifold, things like that. Seeing sources, spirals which go inside in and collapse on a point, spirals which come out of a point, centers where critically the system lurges on one particular, where the trace is zero and it is staying on a particular tightrope kind of a scenario, where just a point is there and consistent oscillations are taking place around that point, and saddles, where on the other side everywhere we can have saddles. And these are very common, where in two variable one dimension though converges, the other dimension does not let the system to converge. Okay, so this was the entire Poincaré diagram for classification of the phase plane of these linear systems. And today we are going to use these linear systems to model some simple linear models of friendships. Now, as you can understand, that friendships are beautiful because we have these relations. We don't know from who was. I mean, the first friend we have was like when we didn't even understood the meaning of this word friend, right? But friendship could be critical because the two persons those who contribute in this particular relationship might not have similar personalities, might not have similar idea about each other's feelings, might not have equal involvement towards the relationship, right? And this is just a toy model, and you are I mean, quite mature to understand this. These things work. This kind of situation of friendships can work everywhere, starting from economics and foreign policy, and everywhere these things work. But we will do with the simple logic of friendships, and I'm sure that you will be able to convince yourselves that these models are basically applicable to various different problems. Okay, but we will stick to friendships because that is something that we can simply understand and interpret. So let us consider the famous friendship of Jay and Viru in Sholay, and let us just take that for the model. Okay, so let us consider that we have two equations, dj dt and dv dt, just like the simple two variable linear systems that we are considering. Just consider something similar to it, and there we have these terms, like you had ax and dy and cx and dy. Just like that, I have here aj dv, cj dv. J and v are the variables. What are these variables? What do they signify? We are modeling, so this variables must have some physical meaning. So you can think of that j's feelings or friendly feelings for Viru, and V is Viru's friendly feelings for J, or something like that. So the sign of this quantity J or V, it can be positive or negative, and if it turns negative, that means that it is going to in a bitter direction. It's like of a hate situation, and if it is positive, then it's a very friendly situation. Okay. A, B, C, D are all constants, and we will see that how versatile this could be to determine different friendship styles. So this is a simple model that tells you that how Jay's feelings for Viru and the Viru's feelings for Jay can change over time, depending on how they are reacting to each other's actions and each other's affections towards as the time goes on. Okay, so what do we see in this model? It's a simple linear model, just as we were considering up until now. So Jay's feelings for Viru, that is the friendship, how it changes with time. It depends on how Jay feels himself, and it also depends on how Viru is feeling for him. And similarly, the other way around. Okay, so in friendship, as it's a bidirectional thing, both ways it should matter. Okay, so you can just simply map it to two collaborators who are trying to collaborate and do some research. You can map it to two companies which are trying to collaborate and make a new product. You can map it to two countries which are lying side by side and trying to work out a good and static foreign policy, right? So you can just choose your place of application according to your needs, but something like this we are considering, where a simple linear model of each other's feelings is controlling that how that feeling changes over time. So is the model clear? That this is the simple model, and what does it mean? Is it clear?
Yes.
Yes, ma'am.
Okay. So now let us just look at that how A, B, C, D, these four constants are basically going to control the entire thing, right? So they are positive or negative or zero. That is going to reflect that how one's feelings or one's actions control the actions of the other party. So what different things can happen? Let us consider that one particular equation. Okay, so let us consider that we are just considering J's equation for now. So dj dt is aj plus bv. That was the equation. So how can you categorize and map the behaviors of a person along with this physical mathematical parameter of A and B? Let us see. So if A is equal to 0, what is meant by that? That means that how J changes with time is not controlled by J's current value. Okay, whatever the value of J at this point in time, that is how much J feels for Viru, does not matter, does not contribute of how J, that in the next step the value of J is going to be. That simply means that J is kind of out of touch with his own feelings, right? He does not understand that he's really caring for Viru, but he does not understand that. Similarly, if B is equal to 0, that simply means if he is oblivious for towards the other people's feeling. So if Viru cares for him and Viru does some good things for him, that does not matter. That does not contribute of which direction J is going to vary over time if B is equal to 0. If I put B is equal to 0, that means this entire term goes off, and that simply means that how J changes with time is not affected but by what is the value of V at that moment in time. Okay, what is the level of friendship from Viru's end at that point in time. Okay, so that is meant by B is equal to 0. Now let us consider some other critical conditions. Okay, what if A is greater than 0 and B is also greater than 0? Okay, so that simply means just consider it mathematically, and from there try to interpret the behavior in a physical space. Okay, that is what we do as modelers, as trying to model or understand some physical things. We take the help of the equations and try to see that if I change this term in a particular way, how that particular change of parameters is going to reflect in a phenomena in my real world, and we try to give that feedback towards this equations once again. Okay, so here let us concentrate on the third condition. Okay, I'm taking very slowly. I'm trying to take this really slowly. So A is greater than 0. That means if at a certain point in time J is 1, okay, and if at a particular point in time J is 100, that difference is going to control that what is going to be the value of J in next point in time. So the value of J is really giving itself a feedback, right? So if it is 1 currently, and you just ignore this entire term for now, Okay, just see that how J controls dj dt. You can see an exponential growth if A is greater than 0, right? So that means that if a little bit caring is there in mind of J, then it grows exponentially over time. Similarly, if there is a little bit positive feeling or positive behavior from Viru's end, that also makes it exponentially grow. That means this person is too eager to make a friendship, right? So this person, this particular equation, if A is greater than 0, B is greater than 0, that simply means that reflects a character of a person, okay? And that tells you that if there is a little bit of chance of getting a positive reaction from a person, this person is too eager to make a friendship. Okay, this could be a country, this could be a company, this could be anything. But in our model, this is a person, and he or she is really too eager. Okay, let us see the other one, this one. Okay, try to interpret them on your own now. I guess you understand that how it is going, right? So let us consider if A is greater than 0, that means it depends on his own feelings. If A is greater than 0, that means if J is positive, it grows exponentially. If J is negative, it decays exponentially, right? It is completely controlled by J's value. But B is negative. That means the other's feeling does not matter that much. Okay? B is less than 0 means the other's feeling does not matter at all. So even if that person, the other person, is trying to do something good for you, trying to contribute something significantly, you are not interested to know about that. Okay, so this person is too narcissist. That means he is only thinking about himself, his own feelings, whatever he is thinking, that is the only important thing, right? So that is the second pair of equations that we can have. Okay, let us consider the third scenario. The third scenario, now I think you will understand it. A less than 0 and B greater than 0. And I'm calling it too cautious. Why? Can anyone tell me? A less than 0, B greater than 0. Why am I calling it a too cautious person? Anyone? So let us think about this. Okay, so A less than 0 and B greater than 0. That means in this particular equation, whatever the person feels himself, okay, so if A is less than 0, that means A is negative, right? So his own feelings is having a negative effect on the dynamics. That means if he starts caring too much for the other person, he feels that maybe I should back off. Okay, and if the other person becomes too much aloof, then he again rushes and tries to retain the friendship. So this person is too much cautious about which direction the friendship is moving, and his own feelings are basically contributing negatively in the dynamics, where the other person's feeling is contributing positively. So he is too cautious on that how the other person is behaving. That is okay. If the other person is positive, then he moves forward. But if he moves forward, because of this negative value of A, that drives him to come back again. Okay, so if J increases or J has a larger value, that basically contributes to a negative exponential kind of a behavior from only if you consider the J side of the axis, the one side of the axis. The other side of the axis, the other direction of the motion of the dynamics is basically positive, because if B is positive, that means the other person's feelings are driving it in a positive direction. Okay, so A is negative, B is positive, is a too cautious person. And if both are negative, then that's a really bitter person. For even if he does not have any feeling, and if he has, then that always contributes negatively. And if the other person also tries to make a friendship with him, he goes in the other direction and rejects everything. Okay, so dj dt has no way to grow because both A and B are negative, and it falls down exponentially, and it drops down to 0. Okay, so these are the different personalities that you can have, not only personalities but different kind of styles, so to say, to deal with a friendship that you can have in a system. Okay, so we have considered all the possibilities because we have considered all the values, positive, negative, and zero for the coefficients a and b. Okay, so I will stop here for a moment and ask you that how clear or how vague this particular idea is sounding right now. Is it okay?
Hello, ma'am.
Are you yes, yes.
It's looking like Sheldon's Cooper's way of friendship. They can,
What? Yes,
yeah,
yes.
Sheldon Cooper, he makes like this kind of modeling and everything. So, as you are putting friendship, so it's looking like Sheldon Cooper is doing something.
Yes, it's kind of like that, but basically, I mean, we can take any example from a physical world, that is true, but friendship is something that is very much known to us, and for that we have dealt with so many friends with our life in our lives, so that to understand these different styles that I am mentioning here, different personalities, I am sure that all of you have seen these people around. Okay, so that is why I have chosen friendship as a model, because it is very much easily relatable to you. But mm, this part you can be very sure of, that these models, this kind of behavior is not only seen in people in our friendships, right, but this can be very much applicable to several different fields, where this kind of behaviors are there in two political parties, are there in between two companies, are there in two countries, and so on. Okay, you can just try making different systems, even in what should I say, in different in several different things. You can just go on and apply these problems. Okay, so the thing is that if you are you just try to think about these positive or negative values of these parameters and try to relate it to a person. Okay, and the next step would be take a pair of people now. So it's a friendship, right? So there is always another equation of dvdt there. Okay, and it always there are always possibilities that c and d, the other two parameters in the other equation, can also have similar kind of different natures, right? So if I move on, that Jay can have 6 different styles, all these 6 different styles. Jay can be a person who is out of touch with his own feelings. He could be oblivious of the other's feeling. He could be too eager, too narcissist, too cautious, or a bitter person. Jay can be of these 6 types. Okay. Similarly, Viru can also be of these 6 types. Okay. So that simply means that 36 different kind of pairings you can make out of it. Different people meeting different people, and you can actually try to see that how complicated it could be, how different kind of parameters you can choose, because all these parameters could be positive, negative, or zero. Okay, so all these parameters could be positive, negative, or zero. 4 parameters with 3 choices. That means totally you can have 3 to the power 4, like 81 combinations. And there you will have some symmetry. And if you drop it out, then at least 45 of them are unique. Okay, so maybe A negative, B positive, C positive, D negative. Like that, you can make 45 unique combinations, unique friendships, unique pairings. Okay, with 6 styles of J and 6 styles of Viru. So like in this way, you can basically see that how different possibilities are there if you consider a two-party interaction, and this two-party interaction could be anything. Okay, so if you are considering a two-party interaction, in most of the time nonlinear equations are not very essential. You can interpret those systems with linear equations only most of the times, and these linear equations can be this much have this much variety in them. Okay, so the assignment that I have planned for you is basically some of these unique pairs that I'm going to pick up and give you to solve. These will be similar in some aspect because all the problems, solution of the problems are basically similar in nature, but the results will be utterly different. But the main goal of the assignment is going to be that you have to try to interpret the equations beyond the equations. You have to try to map it to the real life problem of friendship. Okay, so you have to try to understand that are these two friends are if this kind of if these two people meet and start a friendship, then is this going to be a friends forever, or this is going to result into a war at some point, or this is going to be like a boring friendship after a certain point, or these people will start hating each other after a certain point, like that. How can I conclude? I'll just see that what are the values of J and V, the two variables that represent the feelings of these two parties for each other, how their values are going to change over time, and what is the value that I get at t tends to infinity. Okay, at long time limit, is J and V both positive? Is J and V zero? Is J positive, V negative? V positive, J negative? What are the different solutions that I can have if I have a particular kind of pairing? If I have two people who have a very distinctive nature, and I will define that nature for you, 6 different natures for you in the 6 different assignments that you are going to solve, and try to figure out that is this, what is the fate of this friendship, something like that. Okay, so not just equations, beyond that equations, you have to think it in terms of the real life problem. And because it is not something of rocket science, it's just friendship, so I guess you can do it. Okay? So let me just, as an example, what I expect from you, let me just tell you that with one of the examples that I have planned for you. This is not part of assignment, this is just an example that I am giving to you. So identical cautious friends. Okay, let us see each and every step. I will just try to explain so that you get a flavor of it. Okay, identical cautious friends means, the identical means they're the two equations that I have. So if you have a notebook, just scribble on it that dx dt is equal to ax plus by, and dy dt is equal to cx plus dy. Okay, so if I'm talking about identical friends, identically reciprocating their each other's feelings and also their own, right? So that means A is equal to D and B is equal to C. That is meant by identically reciprocating each other's feeling. Identical friends, identically involved in the friendship. Cautious friends means, cautious we have already defined, right? Cautious means that being cautious about their own feeling means A becomes negative. A becoming negative, and similarly then D is also going to be negative. That means if they move too much forward, if they take 10 steps forward, that drives them to take again 10 steps backward, something like that. Okay, they are too much cautious, that maybe I am too much involved, or I am contributing too much into this. Similarly, B is greater than 0 reciprocates other friends' behavior. So the friend's behavior is reflected positively, but own behavior is being reflected negatively. A less than 0, B greater than 0. Okay, so A equal to D and B equal to C makes the other, defines what is going to be the other parameters as well. So D is also less than 0 and B is greater than 0. So first step, once you have your problem, just decide that what is going to be the values of your parameters, positive, negative, or 0. Okay, that is the first step. So we'll start from a real life problem, we'll go into the mathematics, we'll solve the mathematics, and we'll come back and interpret results for the real life. Problem. So what is the fate of the hello?
Ma'am, hear you. I could not hear you.
How far have you heard?
Uh, that was it.
Why A equal to D, B equal to C, this part you have heard? This part is clear?
Yes, tell for
No, ma'am. B equal to C part is not clear.
Yeah, so here we had identical cautious friend. Cautious means extremely cautious about own behavior. So A is going to be negative. B is going to be positive because reciprocates the other friend's behavior. Okay, and because they are identical, that means their behaviors are identical. That means their involvement in the friendship is identical. Okay, so A is going to be equal to D because just if you just write these equations, dx dt is equal to ax plus by and dy dt is equal to cx plus dy, then A and D are basically reflection of their own behavior and B and C are basically the coupling term, reflection from the other side. Okay, so if they are identical, that means B is equal to C and A is equal to D. Okay, so we will start with one real life problem and we'll try to write down the equations for that problem. We'll solve that problem mathematically and come back and try to interpret the results for this particular system of identically cautious friends. So identically cautious friends, the questions we are trying to address is what is the fate of the friendship. Okay, so this is just an example problem for you. You can see that I have already set A is equal to D. This is supposed to be D, right? I have set A is equal to D, D is equal to C because their involvement in the friendship is identical. They are identically cautious. So identical is being reflected in their equations. Cautious, that means A is negative and B is positive. That is our description of a cautious person, right? In that slide, we described different people of different notions, and there we had two eager, two narcissist, two cautious, and two bitter. Four kind of people. So this is the person who is too cautious. Okay, so both of them are cautious. So they are identical and cautious. So from there you can figure out your A matrix. You can figure out the trace and the determinant of the matrix, and now you know the sign of A and B. Okay, from there you can conclude that if B is greater than 0, then what is going to be delta? You will see that that is positive, and the trace of this matrix T is A plus A, so A plus A is going to be negative. So trace is going to be negative and determinant is going to be positive. So in the point array diagram, you can quickly locate that where this particular set of equations are going to sit. Okay, so you can locate where this particular pair of friends will be placed and what is going to be their future. Okay, so if I have trace negative and determinant positive, then what is the future of this system? The first thing we notice is that the roots are going to be real because t square minus 4 delta is a positive quantity. Okay, so no oscillations are going to be there. There will be no oscillations. There will be some deterministic behavior that we can say simply without any oscillations. So let us see. So this is the point array diagram, right? T is less than 0. The stable node delta is a square minus b square. So a square minus b square will be greater than 0. Then only I can have a stable node. And if it is less than 0, then I am going to have a saddle point. So it depends on the value of delta that I am on this side of the Poincare diagram or in this side of the Poincare diagram. Okay, so determinant is this axis. If determinant is positive, then I am on this side. So it depends on the value of A and B. How, if A is greater than B or B is greater than A. Okay, that basically controls that which way the friendship is going to drive. So if I have, is it clear or is there some confusion up to this point? Hello, can you hear me?
Yes,
Clear,
ma'am.
ma'am, clear.
Clear.
Yeah, so do you understand that how to solve these problems?
Yes, ma'am.
Okay. Okay, so that means you have to conclude that what kind of a fixed point or what kind of a saddle point or spiral I am going to get. Okay, so identical cautious friends, for them you can figure out what your lambdas are going to be, what is going to be your eigen directions. You can solve that equation in terms of A and B only. In all the equations you will solve them in terms of A and B only. Okay, solve them, see that what are the directions that you are getting, eigenvectors, eigenvalues. From there you can draw the phase portrait, right? You can draw the phase portrait from there and you can conclude that what happens if A is greater than B, that is A square is greater than B square, or what happens if A square is less than B square. Okay, so if you have A square is less than B square, you will see there is a saddle, and in the plane, XY plane, you can draw the diagrams, right? The stable manifold, the unstable manifolds, you can draw. We learned how to draw these things. But what does that mean in real life? So in real life, a saddle or say a node like this points out towards something, right? So a node like this, which is a stable point, if A square is greater than B square, then it comes down and boils down to a scenario where what is the fixed point here? What is the fixed point where all the trajectories are coming and entering? J is equal to 0, V is equal to 0, right? Origin,
Yes.
right? So J is equal to 0, V is equal to 0
Yes,
if A square is greater than B square, right? So that what does it mean for a friendship? That J is equal to 0 and V is equal to 0 in long term. Wherever you start, you end up there. That means J was J's feelings for Viru, V was Viru's feelings for J, right? So if both of them are 0, J is equal to 0 and V is equal to 0, then what kind of a friendship is that?
No feeling.
No feelings.
no
No feelings.
friendship.
No friendship, right? It's kind of a boring relationship that went like you forgot that friend or something like that, right? And why that happens? Why you became like an unknown person, right? You became like an unknown person. And why that happened? Because A square was greater than B square. And what is A and what is B? If you look at your equation once again, A was how much J is concerned about himself, right? And B was how much J thinks that Viru is also thinking about him. Okay, so if his self-consciousness becomes more than his response to Viru's behavior, then you are bound to go to a direction where you will no longer remain friends. Okay, so that matches, like physically that is something that should happen, right? If you are too much cautious about your own feeling and you don't care that much about the other people's feeling, then you are not supposed to be a friend of that person in long term, right? So it reflects what we can so that is why I have chosen this problem, so that you can understand positive and negative values of J and V and A, B, C, D, all the parameters, and you can interpret them very easily from your real life experience. So if A square is greater than B square, that means his own feelings are more dominating than the other person's response to the other person, then it must go to a direction where you will completely forget that friend, and you will become like two unknown people, two strangers at long time limit. Okay, so last 1 minute to stop here and talk about the saddle point. So what happens if I have a saddle point and A square is less than B square? What is the directions that we are heading in long term time limit? What is the value that we get in long term?
Yeah, good friend, man. Infinity.
A good friend is just one side of it, right? J positive, V positive means J positive, V positive, both of them positive means that they are very good friends. But what about the other three quadrants? So we never ever have a value where one of them is negative and one of them is positive. So that value we don't get, right? So second quadrant and fourth quadrant, there is no line going in that direction. All lines are coming out of that direction, right? But we have a solution in long-term limit. We have some trajectories going towards this direction where you have J negative, V negative. Okay, so why is that happening? If you care less about yourself and you give more importance to the behavior of your friend, why sometimes it can happen that it result into a war, something like that can happen, that you hate that person really, really high. It's not like a stranger. You really hate that person. Can that happen? What does your real normal life experience say? Can it happen? That you are giving really your importance to how the other person is behaving, and that can drive you crazy because the other person is not behaving in a way that you are expecting him to behave. It can always happen, right? So this system where you are not too cautious about your own feeling, but you give too much importance into the other person's feeling, a little bit of perturbation can drive it either to one direction, what is going to be like a friend forever, or it can also drive it to the other direction where it is going to be a war for lifetime, something like that. Okay, so you will say like after 10 years also, I really hate that person. I thought he is a good friend, but I completely hate that person right now. So that also can happen. So this is saddle, right? Completely like two diverging solutions can come out of it. So you understood how we analyze the system in terms of equations, and you also saw that how we can interpret this solution in terms of like what should I say, the real life problem, right? So that is what I want you to do. I will send you some separate personalities of friends, pairs of friends, and you are supposed to do this same analysis, the mathematics as well as the mapping of that mathematical idea to real life. I will send you a format of a paper, okay, a journal paper that is going to be a really good practice for you. I believe you will be immensely enriched. So what you are supposed to do is you are supposed to write a 2 to 3 page report on whatever is your finding. You are supposed to give a title of that. Suppose just assume it to be a paper, okay? So title of the paper, the two authors, a small abstract on what is your findings, what did you do, and what is your findings, and then you simply write that what kind of analysis you did, what kind of figures you got, and what kind of interpretations you can make from your results. Okay, so plots you try to make it using Excel. I have already shown you how to make those plots using Excel. So don't draw these plots on your hand. Try to make actual plots with actual data in Excel. Okay, so try to plot those in Excel. Just take those photos and paste them in your Word file and try to make a good concrete report out of it. Okay, so we are discussing it today. I will circulate the assignment today only, and you will get 1 week's time. You take your time and you prepare a nice good report, just 2 pages or 3 pages if you need, a nice good report on your particular problem. So the problems are going to be really different, and I am also going to add a small portion where there will be a room for innovation if you want to do it, but it is completely up to you. So the main problem is just to solve this problem with your pair of friends. Okay, so is it clear that what is expected for the assignment?
Yes.
Okay, so I will circulate the assignment today and you just have a look. If you have any confusion, you get back to me by today or tomorrow, right? So that just don't tell me after 1 week that I could not understand my problem. That is going to be really bad then. So take your time with your problem and sit together with your partner. Okay, so don't make it like one man's job. It's a good exercise to do it together. So sit with your partner and try to draw some beautiful conclusions out of your equations. Okay, so I will put the submission deadline on Saturday next week. Okay, so I will circulate it today, and Saturday next week is going to be the submission deadline. So let us stop here for today. I already took too much time. Let us move on to the other class. I hope. I think Hirok sir is already waiting there. Okay, so bye bye then. Huh? See you in the next class.
Okay, ma'am. Thank you.
Okay, bye.